everybody. Welcome to Transport Lab Seminar. It's so nice to see everybody here in week one. I'd start by acknowledging the traditional owners of the land, that's the Gadigal people of Zero Nation. I pay my respects to their elders past, present, and emerging, and I extend my respect to any Indigenous people joining us here or on Zoom. Okay, it is such a pleasure to introduce an old friend. Today we have Shantanu Chakraborty, who is going to be talking to us about his work with zero emissions transport modeling. But I have known Shantanu since he started at UNSW. He did his PhD there, working on dynamic traffic assignment, managed lanes for connected and autonomous vehicles, and route optimization for on-demand transit, so a variety of things. He's worked with Keolis Downer, with Transport for New South Wales, and GHD, so I'm looking forward to whatever he has to tell us, and I will let you know when there's about 5-10 minutes left so we can do some questions.
Cool. Awesome. Yeah. Thanks, Emily. It's great to be here. Thanks, everyone, for coming. And before coming here, I actually did look at all the other presenters who come from the Transport Lab, and I feel myself very fortunate to be here and being invited to this in this seminar series. And before, also, I asked Andres that what does my audience look like? Like, are they from the are they from all research students or academics, or they're all students who are doing their master's degree, undergrad, and if they're looking for some industry opportunities and things like that. So yeah, I mean, his response was mainly research students and also master's students and maybe few academics. Is that still true? How many research students are here? If you can raise your hands, and also masters, undergrad. Okay. Cool. All right.
We have 7 people on Zoom, and they both look like active transport students.
Great. All right. Yeah, I mean, that's why I kind of tailored my talk in a way that it gives you the flavor of both industries and how, of course, I mean, most of you might be familiar with how academic projects are when you are in the university, but once you step out, what kind of projects you are generally involved in when you are working in the industry as a consultant, as a transport modeler, traffic engineer, and so on. Right. So I will go through a few projects, both in the what I used to do in my academic career when I was after my PhD as a postdoctoral researcher at UNSW, and what I do right now at GHD. So the overview will look like this. See if I can figure out how it moves. Yeah, cool. So yeah, we will we'll look at a few. Actually, one of my transport projects in academia as a transport researcher. And then we look into a few transport projects in the industry that I am I was involved in those projects as a senior transport modeler at GHD, and also as doing my secondment at Transport for New South Wales. And finally, how can we bring these two worlds together, and can we do transport research projects still when we are in the industry? And also along the way, I might also add, is it really necessary to have a research background when you are applying for jobs in the industry? How can that help while doing projects in the industry as well? So starting with one of my transport projects, and research projects when I was in my PhD and postdoctoral researcher at UNSW, it was on connected and autonomous vehicles, and how can we model a network, a multimodal network where we have both legacy vehicles and connected and autonomous vehicles in our system. So it generally looks like different. These are kind of distracting. Let me just see if I can. Yeah, drag this one. So yeah, when we talk about connected and autonomous vehicles, there could be different levels of their autonomous features. It could be just adaptive cruise control or lane assist, auto steer, and things like that. And as we progress, in the automation feature, there might be different levels. There might be driver. You don't have to be always having your hand on the steering wheel. It could go fully autonomous. So there are different levels, and the way I started to have a look at it, maybe how can we, when we have these different levels of autonomous features in the vehicles, how can we prepare the existing transport network in a way that we can embrace these autonomous features and also kind of welcome these autonomous features in our transport networks. So of course, with an idea of having improved road safety, network efficiency, increased productivity, and energy efficiency. So the questions were, are we really ready to have these different features, automated features in our network? And how do we model network with legacy vehicles, which are the ICE vehicles, the internal combustion engines, and also the connected autonomous vehicle? And also here could be, I'll be talking about the zero emission vehicles as well. And how can we prepare our transport infrastructure to embrace the technology? How the presence of AVs affect the network performance? And if we know the utility and distribution of AVs and LVs, the legacy vehicles, can we design AVs as a service, the fleet service for serving the commuters in our network? And while doing this process, the question that I came up with during my research was, should AVs be provided with a dedicated lane? And what does that mean? It might look something like this, where we might have AV lanes for autonomous or connected automated vehicles, and then we have regular vehicles for other cars. But is it a feasible option, and what are the questions around it? So before we jump into any, before we come up with any question, maybe I'll just give a brief idea what this research was all about. So it's not providing autonomous vehicles throughout the network everywhere. There could be possibilities where there could be some potential links in the network where you can use it as an autonomous vehicle lane or not, right? So and the AVs and LVs can share the other lanes, because we also need to see. So the performance metric was not really reducing a particular type of a particular class of vehicles, their travel time. Sorry. So the idea was, how can we have a performance metric that kind of considers all the different classes of vehicles, whether it's legacy vehicles and autonomous vehicles. So we went with system optimum, the total system travel time of the whole system. And only we switch on those autonomous vehicle lanes in the network if there is an overall benefit in the whole system, not really a particular class of vehicles. So that was the construct, and the main difference between these lanes, the AV lanes and regular lane, was there were higher lane capacity on the AV lanes, and sometimes it could be from our modeling exercise. We found it was sometimes almost double the lane capacity of the regular lanes, especially because of less stop and go, and kind of the whole AV, all the AVs are going like a platoon through the network, higher backward shockwave speed, but the other parameters such as free flow speed and the jam density of the network, it remained the same. So if you look at very basic fundamental diagrams, the triangular fundamental diagram, the traditional LWR model might look like this, and where we have only a certain class of vehicles, and for the lane-based approach, it would be something like this. For the regular lane is designated by the red line, and the AV exclusive lane is the blue line. So the jam density remains the same, but however, the flow is much higher for the AV when the vehicles are traveling on the AV exclusive lanes. So in the methodology of this research was, it had two different steps. The first one was developing a system optimum DTA, dynamic traffic assignment for network design. where the base traffic flow model was the link transmission model, and then the system optimum dynamic traffic assignment formulation was based on that. And then the deployment of AV lanes with endogenous demand, and that's where how the demand reacts to the performance of the network in the long run, and how it can influence the uptake of these connected and autonomous vehicles. So that was the second part of this research study. The solution algorithm looked something like this, where we start with initializing the whole algorithm, where we start with there are no AV exclusive lanes. There all the lanes are for all the vehicles, regular and the connected autonomous vehicles. Then as we go along, based on the traffic flow model, the link transmission model, we update the path travel times, and then based on that, what would be the impact of the mode share, how attractive a certain class of vehicles or their performances in the network. Based on that, the mode share is updated, and then we check for convergence, and then we find out what is the proportion of AVs that will give us the maximum benefit in our network, and how the overall total system travel time is performed. What is the value and how it is actually being impacted when you have more connected and autonomous vehicles in the network. And we did small numerical experiments on this, where we have a motorway network and we have different nodes and there are links, and then we had a few candidate AV lanes. So the green ones, so there are always a path for the regular vehicles to go from their origin to the destinations. But there are a few candidate AV lanes which can be either switched on or off based on how much beneficial it is for the overall system performance. And then we also had some detour added to it, see how the algorithm performs on this small network. So the results of this study was 7 out of 9 candidate AV lanes were turned into AV exclusive lanes for longer detour scenario, and 4 out of 9 in the shorter detour. And there were overall an 11 to 15% of improvement in the total system travel time was observed, and compared to when there are no exclusive lanes. But then to have the maximum benefits from the AV lanes, we have to be in that the optimum share of the AVs has to be around 60 to 77%. That was kind of a tricky thing. If you have only 10 or 15%, it is not feasible to allocate any lane for these AVs. So the overall idea was how we can model these both types of vehicles in the network with this lane-based approach. And the average link travel times had reduced, and then there was the maximum reduction was almost 48%, and there was average reduction in the average travel times, and based on based on the benefits of these AV lanes in the network.
Okay.
So sorry, yeah.
I'm not clear on all of your assumptions here. So the base case, what percentage of the vehicles are AVs?
So we start with there are no AVs in the network.
Is that the base case?
Yes.
So in the base case, the exclusive lanes reduce the average link travel time by a maximum of 48%.
No, when you compared, so maybe, yeah, assuming the average travel time. Yeah, I think that there is so the base case we start with there are zero. There's some mistake there. The base case we start with there are no AVs in the network, and then slowly we try to introduce the number of the percentage of AVs in the network and how it actually impacts the total system travel time.
So when you say you reduce the average link travel time to a maximum of 48%, what scenario is that?
So when we reach around 60 to 77%, that's the area where there are more number of AVs in the network. That's where we get the maximum benefits.
How wide is how many lanes are there?
So that's what we have done it very net. I just showed the network. It's a very small network where we have so these are all lanes. There are 3 lanes, so they are all lane-based methods. So each one of them has 3 lanes, and then in between to create some bottlenecks there were 2 lanes. in the network.
Okay, so each one is
As a lane.
lane.
Yeah. That's how we can switch between AV lane and regular lane.
And so when you turn some of them on and some of them off, the bottlenecks are link 8 and 14 from your graph there, and link 8 particularly because you have detour. So did link 8 get converted to an AV lane or not in that scenario?
So I'm not sure exactly about when these 8 will turn into an AV lane, but then overall, if it's, for example, so the AVs can only perform like an AV on these when it is actually switched to an AV lane.
Right.
So they should perform like in legacy vehicles when they are on regular lane. So only when we see the benefit of the total system travel time, then only it's.
So is there a scenario where link 8 that converted to an AV, one of the lanes converted to an AV lane benefits total system travel time?
Yes. So there we had different scenarios when we compared with the base case, and there were scenarios where we saw all of these being activated as an AV lane to get the maximum benefit. But then if we go to the solution algorithm, it also kind of changes. The endogenous demand calculation is kind of embedded inside, so it kind of impacts the percentage of AVs in the network as well. So that's where it updates the percentage of AVs, and then it kind of says, okay, this is with this percentage, all the lanes should be AV lane, all these green, everything should be switched on to get the maximum benefit in the network.
And then in that case, we had something like 67%.
Yeah, and because it kind of also impacts all the regular vehicles as well, right, their travel time.
So that was the next question. So the system travel time, AVs and non-AVs improves. Does the travel time for the non-AVs get worse?
So if we look at I haven't put the objective function here. Objective function is the number which has the travel time of both AVs and LVs together.
So, right, but I mean, is this like you show whether or under what conditions this would be a Pareto improving solution so that each class of users would be better off as opposed to just an overall solution, because I'm rich enough to own an AV, I'm better off, yay me, but the people who don't own AVs are going to be losers in this scenario and be unhappy, presumably, and will complain. So is there a Pareto solution where they're not worse off?
Yeah, I think in this study we have just combined both of them together to have if the overall total system travel time improves, and it didn't, like initially we thought maybe only with it will kind of push it to kind of 100% AVs to have the maximum benefit from the exclusive AV lanes, but it didn't, because there is a cap on which lanes will be turned on to AV lanes as well, right? We can only, out of all these 3 lanes, only one of them can be. So there are some paths for the regular vehicles to travel. And if you can see, we are always having either 50% or more for the regular vehicles to travel. So in that sense, we are kind of giving a bit more weightage or a bit more importance to the regular vehicles. Yeah.
You don't want to lose all the fun for discussion at the end.
No, thanks for the questions. So yeah, I think, so I will, so that was the kind of, I'll just summarize the research project here. So it captured the user mode choice behavior in the long run, which haven't, from best of our knowledge, hasn't been done before. And the performance metric, it involves minimizing all vehicles travel time, not a particular class of vehicle. And it decides which candidate regular lane should be converted to an AV exclusive lane. And then application for the long-term strategic planning models using this can be, this framework can be used as well. And it can also be used, interestingly, for ramp metering and dedicated bus lanes. So it's not like this idea is not like, it's not, reinventing the wheel or something. We already have dedicated bus lanes, but it's kind of fixed. How about we have maybe dynamic, like based on what is the overall system performance, we can switch on and off a dedicated bus lane or dedicated and autonomous lane. So something like that. So that was one of the ideas. So yeah, so that was the research project. But then I'm going to now switch back to the industry project that I have been involved in. And here you can see, I think might be a bit more interested on if you are really looking to pursue your career in the industry, how the projects are, how different the projects are in the industry. So I will go through a few projects that I have been involved in as a senior transport modeler in GHD. So one of them was in the easing Sydney congestion, the ESC project, and it was there are different types of projects that was there in this, and the client is Transport for New South Wales, where we had the top this corner is the benefit realization, and then we have some pedestrian movement and traffic study, few parking study, and then a new bypass that is being constructed. So if I go one by one, so one of them was benefit realization project. Now, what is benefit realization project? So if we, for example, there are transport infrastructure upgrade in the network, right? So there were few additional lanes, and there are millions of dollars has been invested, and the network has been upgraded to maybe 2 right turning lanes, or maybe longer turning length and of a link. How it actually benefits the network in terms of travel time improvement, traffic flow, is the road safety is better now, is it based on crash analysis, if there are any additional bus lane that is added in the network, is it really beneficial for the overall transport performance? So those were the type of projects that were clubbed into this benefit realization set of projects. So how it is actually done is the objective of these projects are if there are any bus service improvement, okay, improve the reliability of the bus services. And how do we do that? Maybe using some tool like an on-time running of buses. I'll go into it in a minute. And then how, if there are some upgrades in the network, how it improves the traffic flow, how it improves the travel time, how it improves the safety, based on the data that are pre-construction and post-construction. So before the upgrade of the network, what is the traffic flow, and after that, what is the traffic flow and travel time and the number of crashes and things like that. We start with analyzing a timeline first. For example, I have taken a sample project here, and we see when the construction period actually happened. In this case, it overlapped with the COVID period, and we choose the time period which we should use for pre-construction study, and then with the construction period, then we're giving some time for the traffic to normalize, getting used to the upgraded infrastructure, and then we choose the post-construction study, and also considering the holidays and things like that. And then we do the data analysis before and after. There is another sample of a road network upgrade. This is the King George's Road and Canterbury Road. And here you can see there are additional right turn lane with the combined increased storage, and then high entry slip lane for a better, safer left turning movement, additional right turn with again increased storage, single high entry left slip lane. So these are the kind of upgrades that has been already done. So there might have been some modeling exercise that has been done before. Based on that, these upgrades were chosen. Now they're already done and the network is improved. How it is benefiting the overall transport performance in the network. And we do some first the volume analysis. So we have the TCS plans before and after, and each one of these you might already know the SCATs detector that are there. If you look at the intersection closely, there are always some cutouts whenever there is a signalized intersection. That means there are loops under that, and that tells you how many vehicles are going through. And if the network is upgraded, now those SCATs detectors are upgraded as well. So we have pre-construction and post-construction SCATS plan, and then we study the traffic flow and how it is improved from the before and after the upgrade. Similarly, we have the HERE database for travel time, and where we see what was the travel time in the link and which is upgraded. In this case, it is King George's Road and Canterbury Road intersection, and we have we take a particular stretch of that link and see if there is improvement in the travel time before and after study. We generally take maybe 2 to 3 months of data pre-construction, 2 to 3 months of data post-construction, and see what kind of benefit. And these are really important to kind of justify the amount of investment that has been done for improving the transport network. Then we have crash analysis. We consider again the same intersection, and we find out what are the different types of crashes that has happened in this intersection. In this case, what generally happens is because the upgrades are quite new, generally for crash data analysis, we take 5 years of data together to see what are the kind of crashes that has happened in the network, and then we do post-construction, but generally we don't have 5 years after the construction has been completed. So in that case, we come up with anticipated crash savings based on our professional judgment, whether, for example, if there are more rear-enders crashes, and then we have an additional right turning lane, that there is a possibility of potentially those crashes might get reduced. If there are any pedestrian movement crashes, and if there are upgraded pedestrian crossing, and how it is actually, there could be anticipated crash savings in those areas as well. So these are very important when it comes to the road safety component of those upgrades. And few projects might have been, the main idea behind upgrading an intersection was to improve the road safety. And then comes the bus on-time running analysis. For example, there is some additional bus lane that has been added, or there are any kind of bus service improvement that has been done in the network. So how can we actually, how can we quantify that, yes, it is the bus service has improved in the network? So then we do something like a on-time running assessment, which we go through each of the bus stops and see what time they're supposed to reach and what time they are actually reaching, and then we assign the on-time ratio to it, and then we kind of say, okay, yeah, the bus service has been improved. A few examples of the data. This is how the data looks like. We have scheduled hour band and their arriving time and departure time, and then we find the OTR, the on-time running ratio. And if we see, this is another sample. These IDs are the bus stop IDs, and we see before what is the on-time running ratio, and after what is the on-time running ratio, and then we see what kind of benefits tangibly that is it's making in the bus services within the network. Another project in the that I have been involved with, that was the Forest Road pedestrian bridge project. Here what happened here, there is the Forest Road and then the Lily Street. So in 2019, there was a vehicle turning left, and where a school kid was crossing the road, and there was a collision, and the school kid died on spot. And so the whole idea about this project was, how can we make that crossing more safer? And one of the options that was in front of us was having a pedestrian bridge at different, find out the best location of a pedestrian bridge so that there is school kids can actually cross the road safely, and decide whether to have these at grade level pedestrian crossing there or not. That's another project that was quite different from the benefit realization one. As you can see, there were a few site visit photos where kids are crossing the road and where it's kind of an unsafe, unsafe locations where crashes might happen. Yeah, so that was another study. And this is the Wilson Street Cycleway. This is, again, we are talking about parking study. In this case, the idea was to have a connected cycleway network in the whole, around Newtown. And for that, only one stretch in that network didn't have a cycleway. So the idea was remove some parking spaces and then provide connect the cycleway in the network. And how can we, and what kind of impact it will be in the local business, because there are loading zones also involved there. And for example, if you're running a business and you have a loading zone just in front of your shop, and then you just take away the loading zone, how it can impact the network. So we come from the space, we have to look into how can we actually have another space which is close by to provide that loading zone for that all the local businesses around. So these are the types of projects. And the final one was the Peak Town bypass, where there is a bypass that is proposed to be constructed, and what are the different factors that we have to look into, because this area also has a lot of heavy vehicles movement. And then we start with during the pre-construction, what is the type of vehicles, what is the percentage of light and heavy vehicles, and then how it is going to impact it when there is this bypass is kind of constructed where all the heavy vehicles traffic has been moved, and then all the local roads gets freed up. Will that be a case? Or through modeling we also see whether there'll be rat running. That means people are kind of avoiding the main bypass to save time and choose maybe other roads. So all these different types. So these are the few examples that you might encounter when you are working in the industry as a consultant. So yeah, these were a few examples there. Now, the next thing I'll quickly go over is the being in the industry. Can you still get involved in research projects? Not many company out there supports that because it's always, it's all about I call it as a putting out fires. When there is project, you have to immediately, there is no time to do more research or dig more deep. And so I always found very challenging. And also from my experience, when I moved from university to industry, it was I felt it was quite difficult for me to fit into that, because they have everything. Even 15 minutes of your time is kind of, you have the timesheets where you have to show that you are working on this project and things like that. So it's hard for you to have that space to think about any novel solution for any problems. But here is one of the example that I have right now. This is some internal research projects. It is still in the ideation phase. So I will kind of run it by you. And if you have any questions and suggestions, we can take on board in this study. So this was about the transport emission modeling framework, where to decarbonize Australian transport networks. This was funded internally by GSG's TX28 research fund. And the motivation of this study was mainly the alarming increase in transport emissions, and how it is going to be one of the largest by 2030 when it considers in the Australian transport context. And then right now there might be a lack of advanced transport emission modeling frameworks, especially in Australia, to estimate and quantify the impact of these zero emission vehicles to decarbonize our sector. But that being said, how can we have an emission modeling framework which has both the ICE vehicles, the internal combustion engine, and also the ZEVs? And that was the idea behind this study, to have that framework, transport emission modeling framework, ready in the Australian context, so that we can move towards the net zero target in Australia. So here, of course, there might be in the Australian context, we haven't found any transport emission model which has both zero emission vehicles and ICE vehicles together, and considering only the emission modeling. We also had a plan of adding the connected and automated vehicles here, but that might be at a later stage. But here you can, we didn't have enough time to get into dig more into the literature to find out if anything is there in Australia right now. But then we are, based on our understanding, we definitely need these evaluation frameworks to assess these different decarbonization strategies in the when it comes to the Australian transport conditions. So the objective of this study that we have framed is develop a multi-class traffic flow model involving ZEVs and ICE vehicles. And of course, there will be different emission parameters for each of them. And how can you establish the transport emission modeling framework to estimate the impact of these zero emission vehicles based on their, again, we are talking about the market penetration. And then we investigate the applicability of these framework in case studies. So we already have, so there is, you might have already know about the Vissim transport model. It has a Bosch environmental component where we can already estimate the emissions by each type of vehicle, and they have some case studies for that as well. So the idea was to calibrate their emission class distribution to fit Australian transport conditions. So there we have an emission, the idea is to develop an emission modeling framework with ZEVs and ICE vehicles and assess their traffic performance, and then calibrate to fit the Australian transport conditions. And of course, coming from the industry perspective, we always look for how this can be commercialized, how it can benefit in terms of our upcoming projects. So that was one of the criteria that we had to involve in our proposal, so that we can get it approved and continue our research on that. So that was the research methodology. Still, we are working on the micro simulation part of it and see how different the transport modeling exercise will be. And we are currently working on that. But the benefit of this would be to establish a platform to evaluate how these transport emission levels are being impacted, and when there are different market penetration of zero emission vehicles in Australia. And just tailored for the Australian transport network context, and how these emission modeling framework can be further extended into areas such as fleet decarbonization of electric buses and other shared mobility services. And the pathway that we see to create that impact is, of course, equip the policymakers and with a tool to assess different ZEV adoption strategies. So giving them a kind of a tangible, like having a platform which gives some tangible values that, okay, if you have this much percentage in ZEVs in the network, how your emissions level will change, and currently also address different transport emissions, where we have different types of emissions which have embodied emissions, operational emissions, and user emissions, which are generally considered in reducing the overall transport emissions in the network. But then that being said, we first thing is ZEV sales are not as projected it to be. Not that many electric vehicles are, the rate at which the uptake is happening in the network is not how it was projected to be. It's quite low. But even with accelerating rates of these zero emission vehicles, there might be significant gap to reach the net zero target of Australia, that is by 2050. So maybe these, along with these zero emission vehicles, there might be other strategies, and that's where all the research that's happening in Australia can help to reach that net zero target that Australia has by 2050. And there could be maybe travel demand management strategies could be one of them, and research definitely needs to look into that to equip Australia with reaching their targets. So so that's the research projects that we are involved in right now. But then it's always hard because we also have to kind of manage both the commercial projects that we have in hand, and also having some time out. Most of these work are kind of we need to do from our personal time, and look into what kind of literature that is available out there and develop a methodology which can deliver this project. So I think that's the last slide that I have, and I think I'm on time. Yeah. And
My name is
Yes, yes, I did mention, I think PTIPs there as well. Let me see. Yeah, so that is from PTIPs. That's right. So these are mostly internal. That's why I haven't even. So this is also a sample. It's if your project is with Transport for New South Wales, then you get the data from. You have to request the data and then get it approved, and then you get it. Then you can get to analyze this. And even if you see all the industry project that I just mentioned, I refrain myself from. Telling you the output of those research, all those projects. There could be a confidential issue there. So yeah, so these are all mainly sample. Yeah.
Yeah, so another question, how much would that be different from GTFS?
I haven't compared it with the GTFS. Generally, we use the GTFS data for our Aimson modeling and other modeling exercises, but in this case, we just relied on PTF's data for our analysis.
Thank you.
No worries.
I have a follow-up question on that. So is this at the stop level or at the intersection? Like, because PTIPS relates to the priority program, which ties into the intersections, but is this about assigning particular vehicles at particular stops priority?
Yes. So all these, the first column there, they are all bus stops. So it's a single bus stop that you can see. So they're all, yeah.
Each vehicle coming stop and stop.
Yes, so and even the OTR is also for each of those buses.
Yeah. So it gets a priority score separately from how that priority score gets fed into the SCAD's priority engine.
Yeah.
Yeah.
Yeah. So it's, the on-time running ratio is totally a different analysis.
More student questions?
Follow-up. So I'm just wondering how many priority was being given to participate on, like from PTIP's update. Like, does it make like late red or like early green or something like to traffic signals? Like from the scarce public priority engine?
So in this case, the study that is done here, it is mainly looking at all those priority and stuff that has already been done. And so we have pre-construction where before the upgrades or any kind of changes for the bus services, what was the bus on time running? And then we apply those, which I haven't talked about here. And then this is post-construction, how the benefit, how beneficial those, as the things that you mentioned in terms of giving priority to buses, less green time and more green time and stuff like that, how it actually impacts the on-time running. So yeah, so that in between part we haven't really got involved with. It's just pre and post construction.
That means that in some of the new updated intersections, they starting more priority for buses with like scan.
I don't like. I think Shannon has mainly been looking at actual physical infrastructure upgrades, and yeah, maybe they do something to SCADs, but you don't know about it. You just know it's before
and after.
Yeah.
Thank you.
More questions? I'm sure people are thinking things. Yeah.
So that's the last. So the title of your presentation was academia versus industry.
Yeah.
That versus is a conscious choice of word. Is it unconscious to use that? Why versus? Do you feel that? Is it like?
So yeah, so the idea that I have for this presentation was just to give everyone a flavor of how different. I mean, versus might not be a current good choice of a phrase there inside. Maybe just to show how different the projects are, and also for the industry, the main thing is everything is so much time bound. Just have to wrap it up and just deliver, And that was the kind of idea I also wanted to give to all the students and that had a big shock when I actually entered the industry where I was given a task and, okay, I have to do it right away without really getting the space to think about, okay, maybe I could do a bit differently and give you better understanding.
What's the time frame that we're talking about?
Yeah, right.
Months,
it's just maybe 3 months, you have to deliver a project within 3 months, depending, of course, it depends on what kind of project you're working on and what kind of support you have from the team. If you are the only modeler in the team, maybe you will have a bit more stressed, and you might have given you might be just working on a single project, but sometimes you have to manage all the different projects because there are not enough expertise in the team who can help you out with this. So, yeah.
I have a follow-up question about that. So you said your last project was an internally funded project within GHG. So what's your understanding as an employee of GHG? Like, what's their business case for having internally funded research? Are they trying to build a reputation as a thought leader? Why do they do it?
I think, yeah. For example, we have output of this whole research study, and then we present it to our clients. Maybe Transport for New South Wales have their innovation group, and we can really go and present to them and show that, hey, this is, you are having this latest report on transport strategies or whatnot, where you talk about sustainability, and our emission modeling framework could be really, it could really help you to reach your targets and things like that. So then we try to commercialize. So commercialization is one of the aspects.
It's like doing the pre-work so that you can sell it later.
Exactly, yeah.
So now, assume you have the experience from the academia and the industry. So I'm just wondering, from the perspective of industry, how would you make you interested in the collaboration grants from the academia side? Because we're working so hard on just for example, the linkage grant to get some funding from the government, but it seems that most of the companies might be less interested in that. I'm wondering, is there any tips or suggestions from your side as a GHG or representing the whole industry?
So since the time I joined GHD, I have been trying to talk to my team and really tell them that it would be great to collaborate and get involved into various research projects, and but then it's always hard because, of course, we are generally under staffed when it comes to deliver our commercial projects, so very less time is available to get into these or even like giving so whenever if you want to involve into these research projects, we want to give our 100%. It should not be just our name is just added there and things like that. So I don't blame them. I see that they also come from that space that there are already so many things that we are involved with, and we have clients really hovering on us to deliver those. So we really don't have time to get into this, but it would be a great opportunity, and I'm so happy that they have agreed to fund internally at least a few research projects, and there is always support if we want to reach out, but it's just taking the time out and get involved in those proposal and grants and get something where we can both university and academia industry can work together. You had a question, David?
Sure. So at the end, you were talking about being net zero and carbon neutral, and at least half of the design projects I saw are going to add to total emissions and make it a less sustainable world and discourage active transport and public transport. So how do you reconcile the contradiction in what you would like to do and what your client wants you to do, or what your client says they want on one hand and what the client really wants on the other hand?
So what we generally, so this kind of discussion we have internally as well. And what we say, of course, the client comes with their idea, okay, this is what they want to do. And of course, we don't just go blunt against their face, okay, you can't do this, this has this much, this will really ruin the entire system. We come up, we do our own research per se and say that, okay, if we go ahead in this path, this will be the impact on the network. So even if they asked us to do just a traffic modeling exercise, what we try to do, adding maybe a sustainability component, having some emission model and show them these numbers. Okay, if we go ahead with adding a bypass in a network, this will be the impact in terms of might add more vehicles on the road, and it might, these are the, disadvantage of having those. But then from our side, we cannot really impose those on the client to say that, okay, this is not this you, but we can just, because we are consultants, and we just tell them, okay, this is what.
Are you showing them pedestrian barriers and pedestrian travel times when you make pedestrians climb the bridge to cross the street, or reduce pedestrian demand, things like that? The King George crossings, I've been there, it's pretty terrible as a pedestrian, and you're making the road wider, which means it's going to be worse for a pedestrian. So is that, even though that's not the performance measure that particular group that Transport for New South Wales is interested in, it's a performance metric that another group in Transport for New South Wales is interested in. How is that getting reported, and how are you measuring that? And your simulation's probably not capturing that fully, and you don't have a demand model attached to this in a lot of these cases, I suspect. So you're not looking at reduced demand for cars or reduced demand for pedestrians.
Yeah, I mean, of course, we don't have the expertise that universities have when it comes to.
When you're a PhD, you have the expertise.
I'm the only PhD maybe in the whole team, and but then even with, I mean, I'll just maybe a little bit of digress there. Even I can have a PhD, but I hardly got any time to even expand on the ideas that I had during my PhD. There are few other chapters which are still remain as unpublished, or more exploration were needed in that, and I just don't have the time because all the commercial projects are just bang 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 on target, and we have to kind of deliver those. But yeah, that being said, I mean, I think that's where the collaboration would be great, at least as an advisor from someone from the industry who can tell, okay, if we are going ahead with this, we might have to look into this other aspect as well. You are making the whole intersection more unsafe when you are, providing for all the cars. But we from our whatever understanding and expertise that we have in our team, we do push for. So each report we always have an active transport impact or public transport impact, sustainability, emissions. So we constantly push for those sections in our report, and even in our presentation to our client, we just show, okay, this is the impact that is going to happen if you. Most of the times they are very receptive to these comments, and they do say, okay, yeah, this is maybe let us go back and kind of have our internal meeting. And sometimes they do come back saying that, okay, maybe you cannot really at this stage, we have to go ahead with the project. Or sometimes they do agree that, yeah, maybe we should come up with some other solutions, and what do you guys think? And then it comes back to us. So we then ask for a variation for our work, that okay, we can provide you something more detailed if you want to go ahead in this path. So yeah, but its overall process, I feel it's quite interesting and exciting, and yeah, it's pretty good when you see the impact is so much.
We might call it quits now, but I think we will be retiring to the tea room for a monthly celebration that does not have any birthday.
Maybe.
No, my birthday is in December. Sorry.
Okay.